Today we're going to focus on similarity and how that applies to right triangles. So a lot of our focus today is going to be on identifying right triangles, but also the properties that go with them. So let's take a look at kind of the beginning of this. The first theorem that we deal with, this theorem 7-3, says that the altitude, which is this line right here with that 90-degree angle, that piece right there with the 90-degree angle, this line, it actually divides this big right triangle into two triangles. And really this theorem tells us that the big triangle, this ABC, and these two little ones are all similar triangles. Now that's going to be helpful for us to use. Also, they're going to introduce this idea of geometric mean. Now we've talked about finding an average or a mean before, where we add everything up and divide by how many we have. But today this section is really going to focus a lot on being able to use the geometric mean, which is when you multiply two numbers together and take their square root. Now, sometimes when they ask us to find this geometric mean, we may have to do more to our answer to get it in the form that they want us to. So in example number 1, it says find the geometric mean of 4 and 18. So if I go to put this in here, 4 and 18, that's how I'd start. Now, the big part of this is it'd be really helpful for us if we could actually put it in a form that they would like. They talk about rationalizing the square root, and that's something that we've done in Algebra 1. Now, to do this, we really have to take these numbers and break them into primes. So it's easy to do 4. Just breaks into 2 and 2. Now, I'm just going to circle those as my final prime numbers. 18 breaks into 3 and 6, and then 2 and 3. Now, if I were going to organize these, this is the way I look at it. There are 3 2's. Putting them in order is really helpful. And then 2 3's. Now, this will be the part either you remember this from Algebra 1 or you don't, so let's just do a little review. In doing this process, it's really helpful for us to be able to find pairs. If I look at these pairs, 2 times 2 would be 4, which is a perfect square root. It's a square root of 2. So basically what happens is every pair that you find is going to be able to get pulled outside the square root. So 2 times 2 is 4, and its square root is 2. 3 times 3 is 9. Square root of 9 is 3. The only thing that doesn't have a pair is 2, so that's going to stay underneath. Really, the way I've taught my students in Algebra 1 is that for every pair there is underneath, it gets pulled out once in front. So on this one, 2 times 3 would be 6. So 6 square root of 2 would be your rationalized answer. Now, there's another corollary that's down here that basically says that the length of the altitude of the hypotenuse, is the geometric means of the segments of the hypotenuse. So in other words, back up here, if I want to find this length, if I do the geometric mean of these two pieces, that'll tell me how long this is. So let's take a look at one where I actually use it. Here's a perfect example of one where I want to find y. So y would be the geometric mean of these two pieces. So to find y, it would be the geometric mean of 4 and 5. Now, just like we did in the last one, I mean, I could put this together and do 20. Or it might be helpful for me to be able to break this down a little bit. Because remember, 4 is 2 times 2. And 5's prime. So that means this is really 2 times 2 times 5. Now, often when I do this, remember we kind of paired these up. So it's going to be 2 square root of 5. So in this little answer box that we're making, we have just found y to be 2 square root of 5. Now, if I were trying to find x, I'm just going to focus on just this triangle. So I have 4, I have x. And I could really use either one of these. I mean, obviously this is my final answer, but this one might help me more here. Okay, let's see what you remember about Pythagorean theorem. Pythagorean theorem says that if I were to take the two legs, which would be 4 and the square root of 20, they would give me the hypotenuse squared. So this is kind of the easier part. 4 squared is 16. When you square a square root, they cancel each other out, so you'll be left with just 20. So 16 and 20 is 36. So to find x, I need to do the square root of 36, which is 6. Now I knew that because it happened to be a perfect square root. If this doesn't happen to be a perfect one, can you imagine me taking my little factor trees and going through and factoring out 36 until all the numbers were prime? Okay. Now, this is a complicated section, probably the most complicated of this entire chapter. So being able to find pieces of this is going to be really helpful. Okay, let's try another example. Find the geometric mean of 3 and 12. So 3 and 12. If I were to look at this, 3 is prime, and then I'm going to have to factor this. So 4 and 3, and 2 and 2. Now listen, if you had gone up here and did 2 and 6 instead of 3 and 4, it will eventually come out the same. So as long as these two numbers multiply together to give you 12, then you're good. So on this one, I have 2 2's and 2 3's. And when I look underneath there, I see perfect pairs. Here's a pair of 2's, so that gets pulled out in front. A pair of 3's, that gets pulled out in front. Nothing is without a partner down here, which means all I have to do is multiply these two together, and that's my final answer. Okay, on this one, if I'm going to solve this kind of maybe 2 different ways you can do this. Probably the easiest is to focus on this x first. Remember how we said 6 is going to be the geometric mean of these two. So that means the square root of 2x is going to have to give you 6. Now this may take a little more algebraic solving. To get rid of that square root, I'm going to have to square both sides. So 2x is going to have to equal 36. Notice when I square this, my square root and my squaring cancel. Divide both sides by 2. Get x equals 18. So I have to find x and y, and I get x is 18 up here in my little answer key. So if this is 18, if I take the bigger of these two little pieces of triangles off, this is y, this is 6, and that's 18. So 6 squared plus 8 squared equals y squared. So if I go to do this, 6 squared would be 36. 18 squared is going to be 324. So together this would give you 360. Now, if you put the square root of 360 in your calculator, it's not going to come out evenly, which means that we are going to have to, if we want to find y, do the square root of 360, and then we're going to have to go through and do our little factor tree. So let's see, 360 would be 36 and 10, which would be 2 and 5. Those are prime. 6 and 6, and 2 and 3. So if I go to list these now, underneath my square root, 1, 2, 3 2's, 2 3s, and a 5. Now remember, I'm looking for pairs. So here's a pair, and here's a pair. So that means 2 and 3 are going to go out in front. 2 and 5 are left underneath. So if I multiply these out, 2 and 3 would be 6, and 2 and 5 would be 10. So 6 square root of 10 is going to be your final answer. Now I'm going to slide up and put this into my answer box. Remember, make yourself some kind of answer box that will really, really help in this section.